Welcome to part 3 of Electrics for Heating Engineers. Today we'll look at heating controls. There are three basic types of controls for boilers. First one is 230 volts or mains controls, and these use a 230 volt switch live to fire the boiler. Second sort is potential free controls, also known as low voltage or voltage free controls, and these link two terminals on the boiler to fire the boiler. They aren't actually voltage free, they tend to work on 24 volts, but there's no external voltage introduced into the system as there is on a mains control. The third sort of controls are open therm or proprietary bus controls, and these give two-way communication between the controller and the boiler using digital communication. We won't go into this in this module, but if you're interested in fault finding open therm, I have produced another video on using the open therm monitor. So the simplest boilers to control are combis. There are no zone valves, no other external parts to worry about other than a programmable room stat. So for this module we'll be using an Intergas boiler, and our programmable stat is a Honeywell CM90 series. So as we can see here, this is a schematic of the terminal connections on an Intergas boiler. It doesn't matter what boiler you're using, the theory will be the same. You'll have mains terminals and potential free terminals. So here we're using the potential free terminals on our combi, which in this case are 6 and 7. We've got main supply going to the boiler, and when there's a call for heat from the CM907, it just links terminal 6 and 7 to fire the boiler. So if the boiler fails to operate and we've checked the main supply, then we need to eliminate the external controls, and we can do this by linking 6 and 7 at the boiler. If the boiler now fires, then we know the problem is with our controls. If the boiler doesn't fire, then the problem is within the boiler. So if our boiler does fire when we link the terminals, our next step would be to link the terminals at the controller, so we eliminate the wiring. If it fails to fire now, then we know that there's a wiring problem. Now, some older combis may have 240 volt control, mains control with a separate timer and room stat. So in this case, we've got a timer which, when it calls for heat, puts a switch live from 4 to 3. The switch live then goes over to our room stat, and when that calls for heat, it puts 240 volts mains voltage on the switch live terminal, which in our Intergas boiler is terminal 1. So if we've got a fault, our first test would be to check that we've got 230 volts on terminals 4 and 1 to eliminate the external controls. If we've got 240 volts here, 4 is your neutral, 1 is your switch live, and the boiler doesn't fire, then we need to look at our boiler. If we haven't got 230 volts there, then we need to look at the controls. So we would investigate further. So the first thing we'd check would be, have we got 230 volts on the neutral and live terminals of our timer programmer down here. If we've got no voltage there, then we've got a wiring problem from the fuse spur or the junction box. Next, we would check whether we're getting 230 volts at the output, terminal 3 of our timer. If we have, then we know our timer's working. If not, then we know our timer's faulty. So if the timer's good, we'd check for 230 volts on the common of our room stat, terminal 1. This proves the wiring from the timer to the stat. Then we'd check at terminal 3, the call for heat on the stat. If there's 230 volts here, the stat is good, and the problem must be in the wiring from the stat to the boiler. If not, then we know the stat is faulty. If you do have an open therm room stat or controller, you can link the open therm terminals, and that should fire the boiler. That's a very basic test which rules out your controller and proves your boiler is working okay on the open therm terminals. And here we have a flowchart which goes through what we've just gone through. So if you do have a problem, you can study that, and that will take you through the fault finding for volt free or low voltage controls. And here we have a similar flowchart for fault finding combi boiler with mains voltage controls. Again, takes us through the sequence so we can find out where the problem is. Now we come on to more complex systems, S-plans and Y-plans. S-plan and Y-plan use zone valves, if it's an S-plan, or a mid-position valve for Y-plan to control the flow of water to the radiators and the cylinder, and also to switch the boiler on. Now, this is the S-plan wiring diagram. S-plan was invented by Honeywell, although these days you can use all sorts of other manufacturers' controls to do it. Here we've simplified the S-plan in a schematic view. There's no neutrals and earths, just the lives. It makes it easier to read. So as you can see from our programmer, if we're calling for hot water, we go through our cylinder stat to fire our DHW valve, which then switches the boiler. If we're asking for central heating, then we would put a live on the central heating side through the room stat, again to fire the valve, to fire the boiler. So our first fault finding step would be to determine whether the fault is on the central heating or the hot water, or if it's both. If it's both, it's likely to be a boiler fault or a main supply fault. So we check for 230 volts at our boiler on live and neutral, and also switch live and neutral. As with the combi boiler, if these are both good, then we have a boiler fault. If the fault only occurs on the central heating, then the first thing we would check is whether the 2-port valve for central heating moves when there's a call for heat. If the valve moves, then you know the programmer and the stat are good. Then check for 230 volts on the orange wire to the valve. This proves the end switch on the valve and would suggest, if the boiler is still not working, it would suggest there's a wiring fault between the valve and the boiler. If we don't have 230 volts on the orange, we'd check for 230 volts on the grey wire. If this is good, it would suggest we've got a faulty end switch on the valve, or the valve not motoring correctly. Lack of 230 volts on the grey suggests a wiring fault. If the valve doesn't move, then we would check for 230 volts on the brown wire. If we've got 230 volts there, then we know the valve's faulty. If we've got no voltage on the brown wire, then it would suggest a fault with the programmer or the stat. So the next step would be to check for 230 volts at the input and central heating on terminals of the programmer, over here, followed by the common and cool terminals on the stat to determine where the fault is. If the fault only occurs on the hot water, then the first thing we check is whether the hot water 2-port valve moves when there's a call for heat. If so, the programmer and stat are good. Again, we would check for 230 volts on the orange wire to the valve. This proves the end switch on the valve and would suggest a wiring fault between the valve and the boiler. If the valve doesn't move when there's a call for heat, the procedure is the same as fault finding for central heating fault, but checking the hot water side of the programmer and the cylinder stat, rather than the heating and the room stat. And here we have a fault finding flowchart for S-plan. And depending whether it's if it's a heating fault on the S-plan, we go to the heating fault flowchart. And if it's a hot water fault, we go to the hot water flowchart. Now we come to Y-plan. A lot of people get confused by Y-plans. It's a little bit more complicated and often catches people out. The Y-plan uses one mid-position valve to control the heating and hot water. And here we can see the Honeywell wiring diagram for the Y-plan. And again, I've removed the neutrals and the earths to make it easier to see what's going on. So, the theory of the Y-plan. When we're asking for hot water only, there's no voltage on the grey wire, no voltage on the white wire. We would have 230 volts on the orange wire, which is actually backfed from the switch live on the boiler. The switch live at the boiler is powered by the programmer hot water on and cylinder stat cool, and the valve would close the central heating port, just leaving the hot water port open. For heating only, we put 230 volts on the grey wire via the programmer hot water off, or if the programmer is calling for hot water, a cylinder satisfied, we would then have 230 volts on the grey wire. This is where a lot of people get confused with Y-plan, that you're putting voltage on the grey wire to turn the hot water off. The white wire would have 230 volts via the programmer central heating on and room stat cool. The white wire is for heating, and the orange wire would then get 230 volts via the valve end switch to fire the boiler, and the valve would close the hot water port, leaving only the central heating port open. If we wanted heating and hot water at the same time, we'd have no voltage on our grey wire because we're calling for hot water. Our white wire would have 230 volts via the programmer from the central heating on and the room stat cool. The orange wire would still have 230 volts, and that would be backfed from the switch live on the boiler. The switch live at the boiler is powered by the programmer hot water on and the cylinder stat cool, and the valve sits in the mid position, allowing flow of water to both the radiators and the cylinder. If there's no demand, the grey wire will have 230 volts, either via the programmer hot water off or the hot water on and cylinder satisfied. The white wire would have no voltage. The orange wire may have about 50 volts feedback from the grey wire, but that shouldn't be enough to fire the boiler, although some boilers do get triggered by this and need to put a capacitor across the switch live and the neutral, and the valve will stay in the position of last demand. Here we can see a schematic representation of the Y-plan with a demand for hot water only. So the wires that are live are shown in red. So we have 230 volts on our hot water on from our programmer. This goes to the common of the cylinder stat, and then the cool from the cylinder stat we put the 230 volts onto our switch live on our boiler. There's no voltage going to the valve. The boiler gets its demand from the programmer and the switch live. Now if we go on to central heating only on the Y-plan, again the live wires are shown in red. So the programmer hot water off puts 230 volts on the grey wire of our valve, and this closes the hot water port and leaves the central heating port open. Central heating on would put 230 volts onto our room stat common, and then by the cool of the room stat we put 230 volts onto the white wire of the valve, and then the end switch on the valve would put 230 volts on the orange wire, and this is what fires our boiler on the switch live. Alternatively, the 230 volts on our grey wire could come via the hot water on and cylinder satisfied terminal, in the case where the programmer is calling for hot water but the cylinder is up to temperature. Everything else remains the same. Now if we're asking for heating and hot water at the same time, again all the live wires are shown in red. So the hot water on would have 230 volts, and the central heating on would also have 230 volts. The room stat common would have 230 volts from the central heating on, would go to the call for heat on the room stat onto the white wire of the valve. On the hot water side, from the hot water on via our cylinder stat to our switch live on the boiler. So the boiler again is getting its switch live from the cylinder stat. If there's no demand on a Y-plan, then the only live we would have would be our hot water off going to our grey wire on our valve, and that could come either via the hot water on and the cylinder certified, or the hot water off. And here we have the flow chart for the fault finding on the Y plan, and depending again whether it's a hot water fault or a central heating fault, we would go to the relevant flow chart. There's the one for hot water, there's the one for central heating, and you just work your way through that logically and it should take you to the right answer. If you're installing a Y plan, you need to test the valve that it reacts correctly in all circumstances, and this flowchart takes you through this in a logical sequence, so you can determine whether all your controls are working properly and your valve is operating correctly. So to summarise, in this module we've learned fault finding controls on combi boilers, fault finding on S plans, fault finding on Y plans. Thanks very much for watching. Hope you enjoyed it.